So I'm going to go over graphing form for parabolas. The first thing we want to take a look at is our parent equation for a parabola. The very basic equation that we can have for a parabola is y equals x squared. And everything's going to be based off of that. So the first thing I want to think about with that is just some general points. So if I would make an xy table for a parabola, -2 squared is going to be a positive 4. -1 squared is going to be a positive 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. I can make more points if I would like. All I'm doing is putting an x value in here and squaring it to get my output. If I want to look at a small graph of that quickly, then my graph would look something like this. There's my 0, 0, 1, 1, -1, 1, 1, 2, 4, and -2, 4. So there's a quick sketch of that parabola. That is the parent function. Now if we look at the general equation for a parabola, it is y equals a times the quantity x minus h squared plus k. We can graph any parabola with this equation. Now there's a few things to take a look at here. First of all, we have an h value, which is our horizontal shift. K value is our vertical shift. And the a values can tell us our vertical stretch or compression. It also will let us know whether the parabola opens up or down based off if a is positive or negative. So if I look at a basic equation here, y equals 2x minus 3 squared minus 5. In order to find my locator point, or the vertex for this, what I want to do is I want to figure out the value of x that makes this equal to 0. So what I can do is take x minus 3, set that equal to 0, and solve that. When I add 3 to both sides, I get an x value of 3. That is my k value. So my locator point, or vertex, for this parabola is now at 3, -5. So anytime you're given your general equation, you set this set of parentheses equal to 0, and you look at what your k value is, and that'll give you the vertex. So now if we go and try graphing this equation, it's going to look something like this. So my parent function is already on this graph, and I know now that my locator point for this problem is going to be at 3 and -5. So because of that, I can take a look at what my parent function would look like if it was adjusted horizontally 3 units and vertically -5 units. My graph would look like this if I had an a value of 1. So if my equation had an a value of 1, like that, I took out the a value there, this would be the graph in blue, and I would be done with the problem. However, the a value is not 1. The a value here is 2, so I need to do some slight adjustments. So if I take a look at my locator point or vertex being at 3, -5, and now if I use my parent function, I'm going to look at all my vertical changes of that parent function. So when I go 1 unit to the right, I go 1 unit up. So in this particular case, what I'm going to do now is when I go 1 unit to the right, instead of going up 1 unit, I'm going to go up my 1 times the a value of 2. That is going to give me a 2. So therefore, my coordinate point is going to be right there. So the same thing for going 1 unit to the left. I normally go up 1 from my parent function, as you can see here. But now I'm going to go up 1 times, again, my a value of 2. So I have that point. So now I have these 3 points. The next thing I want to do now is figure out where next couple points would be. So my next one is going 2 to the right. I have a vertical change of 4. So going 2 to the right, a vertical change of 4. I'm going to take that 4 and multiply it by my a value of 2 and get a value of 8. Therefore, on my graph, from my locator point, I'm going to go 2 to the right and now up 8. And my point will be right there. Very similarly, looking at if I go 2 to the left, I also have a vertical change of 4. Multiply that by 2. And again, I get 8. So I get my next point. So if I clean up some of these extra lines that I have here, I am now left with this parabola with 5 exact points without making a table and without using a calculator. However, let's take one last look at a slightly different example. What if instead of an a value of 2, that a value was 1/2? So now I would have the equation y equals 1/2 x minus 3 squared minus 5. Again, my parent function, I always want to know what my parent function looks like, would be these points right here. Because my new transformed equation would be based off that parent function. So again, my locator point or vertex is going to be at +3, -5. And now when I think about going 1 to the right, my vertical change is 1. And now I'm going to take that 1 times a 1/2. That gives me a value of 1/2, which means that when I go 1 to the right, I will only go up 1/2. I'm going to continue the same idea. If I go 1 to the left, I go up 1 for my parent function. So 1 times my a value of 1/2 is again going to be a 1/2 for going to the left one. If I go to the right 2, I would normally go up 4 because 2 squared is 4. So 4 times 1/2 will equal 2. So now I would go up 2 when I go 2 to the right. And again, on the left side, left 2, up 4. And 4 times 1/2 also is 2. And I get my next point right there. I could continue this out as far as I wanted to go. If I wanted to go 3 to the right, 3 squared is 9. And I would take 9 times my a value of 1/2, and I would get 4.5. So to the right 3, up 4.5. And same thing for the left, and 4 up 4.5. And I could continue that graph as long as I wanted.